Hello everybody. We are going to do operations on radicals today. So the operations that we are going to focus on are adding, multiplying, subtracting, and then honors you get a little division too. So regular, if you want to go ahead and do all of it, it's totally fine. It's not a bad thing. Actually, to be very honest, regular, you're actually getting some honors because really the only operation that you must know is multiplication. But I'm going to show you addition and subtraction because I don't think it's that bad. So I'm going to reinforce this some other things. So we're just going to go with it. Regular, feel free to do the honors topics. It's totally fine. So multiplying fractions, or multiples, what am I saying? Multiplying radicals basically consists of two steps. So step one, multiply the radicands, which is the stuff inside the radical, under one with the under one radical. So multiply the stuff together and make one radical, and then multiply the numbers outside the radicals together so you make one problem. Then you can go ahead and simplify it. That's all you do. So let me show you an example. So we have -3 to the third. Excuse this weird looking 3. No, not Nate. Oh my gosh, guys. My brain just needs to stop. Okay, we have -3 times the cube root of 56 x squared y times 2 times the cube root of 8y squared. I'm sorry, my brain is literally powering down right now. So, according to our steps, we're going to go ahead and multiply the -3 and the 2 because they're outside of radicals. And then on the inside, because they are both cube roots, I can do this. Because they are both cube roots, I can do this. I multiply the stuff inside. So the 8 and the 56 will get multiplied. The x is going to be just still x squared. But the y and the y squared will get multiplied together. Okay, so that's what it looks like. So I go ahead and just do the multiplication. I get -6 on the outside times the cube root of 448 x squared y cubed. Okay, 448 was, I think, one of the problems from your activity. We're just going to go ahead and simplify it now. Because we have one problem, we just go ahead and simplify. So I'm going to do my birthday cake. 448. There's my cake. Let's see, 2 goes in there, so I get 224. 2 goes in that, so I get 112. 2 goes in that, so I get 56. 2 goes into that, so I get 28. 2 goes into that, so I get 14. 2 goes into that, so I get 7, and finally 7 goes into that, giving me my candle. Okay? And then the x squared I can go ahead and expand out. Y you can expand out. Now, if you don't want to do this expansion thing like I've done, you can go ahead and do the shortcut I showed you just by looking for the stuff on the side of the cake and dividing the exponents. That's totally fine. Now, because it's a cube root, we're looking for triples. So I'm just clickety-click. Click. Click. Oh, so annoying. Hold on one second. Just gotta get this done. Actually, I can just move this. That's the easiest thing. So we're gonna pretend. So, clickety-click. I got a triple of 2s, another triple of 2s, and a triple of y's. All those triples can be moved outside the radical with the -6. So that's what I do. The 7 and the 2 x's have to stay put. So now I just go ahead and simplify by multiplying stuff. I get -24y, all being raised to the cube root, not all being raised to the cube root, sorry, -24y times the cube root of 7x squared. And that is my simplest form because I can't take anything else out of the radical, so I'm going to leave it there. Okay? You guys are going to try this one on your own. Okay? This 3 is part of the radical, not an exponent, okay? So it's the cube root of 14n squared times the cube root of 8n. I was nice to you and I gave you smaller numbers. So, beware. Alright, so you try that on your own and you come back. Now, you cannot multiply things unless they are the same root. So unless they are both cube roots or they are both square roots, that is the only way you can multiply them. Okay? You can't multiply a cube root with a square root because they're not the same. Alright? Keep that in mind. Now, adding and subtracting, that's our next thing. there are 3 steps. First thing, we can only add or subtract if the radicals are the same, so kind of like terms. Then we just go ahead and add the numbers on the outside, so treat them kind of like coefficients. Okay? So first we simplify all the radicals. If the radicals are the same, we add or subtract the numbers on the outside and multiply it with I don't know what's up. Oh, and just put the common radical they have in common. Okay? Don't forget about an invisible 1. If they're not the same, then you just leave it. Okay, that's very wordy, but let's go ahead and try an example. So here we go. We need to simplify these radicals first. Okay, because right now they are not the same number inside the radical, so I can't add them as is. However, they're also not simplified. Maybe when I simplify them, they'll be the same number inside. Then I can add them. So we try that. Alright, so 20. I make my birthday cake. 2 goes into 20. I think 2. Oh gosh, this stuff is just in the way. So 2 goes into 20, leaving me with 10, which 2 goes into that, leaving me with 5, which 5 goes into that, giving me my birthday candle. Over here, 125, just doing it all at the same time. 5 goes into that, I get 25, 5 goes into that, I get 5, 5 goes into that, I get my candle. Okay, so I rewrote it out. They're both square roots, so I'm looking for doubles. Oh, and I didn't do the double. So I had a double 2, so it moved outside. I had a double 5, so it moved outside. But they both have a 5 hanging out inside the radical. So now they have the same radical, and the number in front is kind of like a coefficient. So what I can do, because it's the same square root of 5, I can go ahead and add the numbers in front, the 2 and the 5 together, giving me 7 square root of 5. And that is my final answer. Okay? So, if you have questions, write them down. Otherwise, you go ahead and try this one on your own. So you're simplifying each one first. Then, if they have the same number under the radical, you add the stuff outside. If not, then you just leave it the simplified form. And that's all you can do. Okay? Alright, moving on. I'm going through your notes as I have them. Now with subtraction, same deal. Okay, we need them to be the same kind of radical. This is the cube root of 32, this is the cube root of 18. I can't add them or subtract them right now. So I go ahead and work it out. 32. I can take out a 2 and get 16. I can take out a 2 from there and get 8. Get 8, give me an 8. Take 2 out there and give me a 4. Take 2 out there, give me a 2, and a 2, and a 1. Okay? With 18, I go ahead and take out a 3, I get 6, I can take out another 3, and get 2, and I take out a 2, I get my candle. Okay, so I wrote it in expanded form. I also put this invisible 1 because it didn't have a coefficient. We're going to call it a coefficient. It didn't have a number being multiplied with it, so I just made it visible. Okay, this one I'm going to go ahead and take out the triple. Oh, I take out the triple, so it's going to be that 2 that I'm taking out is going to be multiplied with the 1. And this I don't have any triples, so I can't take it out. So, this is what I'm left with. Now I'm just going to go ahead and do this multiplication. I get 2 cube root of 4 minus 6 cube root of 18. They are not the same radical. This is the cube root of 4, this is the cube root of 18. So I cannot subtract this. So this is my final answer. Okay, and I leave it like that. Okay, so now you're going to try this one on your own. Luckily, 1's already fully simplified, so you only have to do 1. I'm very nice to you. So you're going to try that on your own. Okay? And now we're going to go into the honor stuff, which, if you want to continue watching, you are more than welcome to, regular algebra people. Otherwise, you're done. Honors, you have to keep watching, though. Dividing radicals. Okay? It's also called rationalizing the denominator. Okay? Meaning, you cannot have a radical in the denominator. It's not okay. Just like you can't have a fraction in a denominator, it's not okay. Okay, so there's 3 steps. We multiply the numerator and the denominator by the radical in the denominator. So that way it kind of cancels out the bottom. We go ahead and simplify. and then we simplify the fraction as well. Okay? So here's an example. We have 4 square root of 12 over the square root of 15. So our issue is that we have a square root in the bottom. Okay? Now to undo that, I'm going to go ahead and multiply by that denominator on both the top and bottom. I had to do both top and bottom because square root of 15 over square root of 15, that's equal to 1. And when I multiply anything by 1, it's still equal. So it's okay. I don't want to change the problem. I just want to manipulate the problem. Okay? So now we have multiplying radicals. So I'm just going to go ahead and multiply them. So what I get is 4 on the outside times the square root of 12 times 15 over the square root of 15 times 15. Well, I just go ahead and make up big numbers. So then I'm going to go ahead and do my birthday cakes for them. Did I do birthday cakes here? I don't think I did it, like, on the paper, because I was trying to save time, so we'll continue with that. So 180, I went and did the birthday cake, and I ended up getting, like, 2 times 2 times 3 times 5 times 5. 225, you get 5 times 5 times 3 times 3. So you get this in expanded form. I am looking for doubles. So I have a double 2 and a double 5 that I can pull out, and a double 5 and a double 3 that I can pull out. So I go ahead and do that. They leave me with just the square root of 3 on the top. And then I just multiply the stuff. So I get 40 square root of 15, which I'm almost done. Great thing is I don't have a square root in the bottom anymore, which is my main thing. Now, but 40 and 15, they can be simplified. So I go ahead and simplify that fraction part, and I get 8 over 3, and then the square root of 3 remains in the numerator, so that's where I leave it. And that's my final answer. Okay? So you guys are going to try one on your own as well. I would simplify the fraction first if I were you. 2 over 2, you can simplify it and makes your life a whole lot easier. But we will go over this next class, and that's all I have for you. Hopefully this was clearer than the last radical video. I really hope it was. We will practice this, and we will be playing, I believe, Radical Bingo, which has all this stuff in it. So I will see you next class, though. Okay? Bye!